Probstats kids, this is Dr. Callahan with week 16 Thursday. How are you guys doing? Go ahead and pause the following video for the 3 questions on your warm-up block today. All right, so today your notes look like this. So I will recommend that you guys go ahead and either copy this part down or just pay attention to it and then jot your notes down on a separate piece of paper. So today we're going to talk about relative error. Okay, so we talked about the brute force method, we talked about the nearest neighbor method, and also the repetitive nearest neighbor method. So the brute force method is optimal, but unfortunately it's inefficient. The nearest neighbor or the repetitive nearest neighbor and the cheapest link method are efficient, but only approximate. So far, no one has been able to produce an optimal efficient algorithm to solve for the graph theory. And also no one has proved an optimal and efficient algorithm. It is unfortunately impossible. However, this could be you. You could prove this and you could be like the next Euler or the next Hamilton. We can determine how accurate our answers are by using something called a relative error, which the formula is the difference from the optimal solution divided by the actual optimal solution. So looking at this from the perspective of the Willy-Loman-Hamilton circuit, the brute force method essentially has 673 or 76 divided by the actual circuits, including the mirror, which is the following. The nearest neighbor is 773. So in this situation, if we were looking for the nearest neighbor, it will be 773 minus 676. The repetitive nearest neighbor, and before we do that, either divided by the actual, as remember, it's going to be the difference divided by the actual, which is going to be a total of 14% relative error. Because the relative error formula is the difference of the optimal solution, so it's going to be the nearest neighbor, which is 773, minus the brute force, which is 673. And if you divide the difference, 97 divided by 673, it is 14%. The repetitive nearest neighbor is going to be 722. So then your relative error is going to be 722 minus the brute force, which is 676, divided by 676. So if I subtract the difference from the numerator, I will have 46 divided by 676. And then once you divide it, make sure you also times by 100 to convert it to a percentage, and you should have a 7%. The cheapest link has a 741. So again, the relative error, find the difference, divided by the denominator, times by 100, which gives you 10%. All right, so putting all together, in order to find the optimal Hamilton circuit for the graph at the right, you will need to check how many Hamilton circuits to use the brute force method. So let's take a look over here. You have, let's see, 1, 2, 3, 4, 5, 6 different points. So 6 minus 1 is 5. 5 factorial is 5 times 4 times 3 times 2 times 1, which gives you 120 Hamilton circuits. Next, find a Hamilton circuit and its weight starting at C using the nearest neighbor method. So if I'm going to start at C right here, I can go to CI, CE, CM, or CG, or CT. Which one has the shortest or the least expensive route? I think it's going from C to I. So immediately, C to I. So then C to I is going to give you 0.8. Then from I, you can go to T at 5.1, I, you can go to M at 4.7. I, you can go to E at 3.6. I to G at 1.1. And I think G is going to be the least expensive. And then from G, you can go to M at 5.7, G to T at 5.9, G to E at 3.2, and this is the least expensive route. And then from E, you can go to T at 8.1, E to M at 8.2, E to I, or actually we already went to I, so E to, T at 8.1, 8.2, that's it, it has to go to T. So E to T is going to give me an 8.1. G to E is a 3.2. I kind of missed out on a little bit on this. I to G is going to be a 1.1. And then from T, I can either go to M at 0.6, or I can go to, actually that's the only one I can go to. Can't go back to M, I yet. So 0.6, and then M goes all the way back to C at 5.2. So when you add everything here together, so you have 8.8 plus 1.1 plus 3.2, 8.1, 0.6, 5.2, it doesn't give you a 19. Okay, so next one to do is let's go ahead and go to number 3. 3 says find the Hamilton circuit and its circuit weight starting at C using the repetitive nearest neighbor method. So starting at C, once again, it is going to be CIGETMC, which is 19 that we found before. But then we can go ahead and also start at another one. You have to find it. What if I decide to start on I? What if I decide to start on M or T or E or G? Because I already got C. And it's found out that if I were to start at I, this will give me the lowest one, which is at 18.9. If I started at M, it will give me the next lowest one, which is going to be, in a second, this thing got covered up a little bit. Let's try that one more time. Okay, so here we go. Which will give me 19.4. If I start at T, it's going to give me an 18.9. And then, of course, if I start at point F, it's going to give me, or E, it's going to give me a 3, or it's going to give me a 19.4. If I start at G with the weights, it's going to give me a 19.4. So looking at this, which one is going to be the most optimal route? It is going to be either this one here or this one here, because both of them has an 18.9. And because it has to start with C, I'm going to start with C right here, and my path is going to be C, G, E, T, M, I, back to C, which is equal to 18.9 for this one. I can do the same thing over here with this one. If I start at C, it's going to be a C, G, because C goes to G, G goes to E, E goes to T, M, I, C. So do you see the kind of the pattern here? Like, although the order is different, the path is going to be exactly the same, and therefore they both result in 18.9. Okay, so now let's talk about the cheapest link algorithm to find the Hamilton circuit, starting with C. So first thing to do is you're going to go ahead and number out all of the paths. So you have 0.6, which is M to T. 0.8, C to I. 1.1 IG, 1.5 CG, 3.1 CE, and then 3.2, which is GE. I'm going to go ahead and cross out the following. Which results with this path right here. All right, you guys, so let's go ahead and move on to the right side of this. So this is a student survey among some of the most things that you really enjoy and whatnot. So make sure you guys take the time to fill that part out. And then we're gonna go ahead and take a look over here on this side right here. So what I want you guys to do is work on that separately. You're gonna find the shortest path with the brute force algorithm starting at A, nearest neighbor algorithm starting at B, cheapest neighbor algorithm starting at C, E, and then the cheapest link algorithm starting any path you want. Then I want you to find all the possible circuit using the repetitive nearest neighbor method using this chart of the following cities. You're gonna start with Atlanta and then give me the link, Columbus, give me the link, Kansas City, give me the rest, Minneapolis, give me the circuit, Pierce, and then Tulsa. Okay. All right, you guys, that was basically it. I hope you have a wonderful day. I'll see you next time. Take care.